Let's learn about vectors. Firstly, what is a vector? Well, there are two things you need to know. There are vectors and there are scalars. Scalars have a magnitude but no direction, while vectors have magnitude and direction. Some examples of scalar include mass, temperature, time, area, volume, and power, along with many more. Examples of vectors include displacement, velocity, acceleration, and momentum. Scalars are added using algebraic summation, while vectors are added by using vector summation. The resultant of a vector is a summation of two or more vectors. How do we find the resultant of two vectors? On the board we have four cases in which forces A and B are acting upon a particle. In this case, A and B are pulling the particle, so it's shown the particle point and the force is acting by pulling on it. In this case, A and B are both pushing on the particle, and you can extrapolate to show that it would also be the same resultant as if you were pulling on the particle. This now, A is pushing on the particle while B is pulling. You will still have the same resultant force as if both were pulling on the particle. And B is doing what A is doing in this case. B is pushing on the particle while A is pulling on the particle. So there are two methods to finding the resultant vector. This method is called the parallelogram method, in which you have vector A and B acting upon a point, and in order to find the resultant vector, you will need to find the diagonal of the parallelogram. So to do this, you will mimic vector A at this point with the same magnitude and direction, and then you will draw a line from the starting point towards the other end of the parallelogram, and the distance between the 2 points will be your resulting vector. I will now show you how that is done. Just to recap, vectors are represented to scale by magnitude and direction from the starting point as arrows. These arrows form adjacent sides of the parallelogram, which you will then complete in order to find the resultant vector. The next method for finding the resultant vector is known as the polygon method. Vectors are represented in magnitude and direction by arrows once again. The arrows are joined head to tail, forming a chain. The resultant vector will be from the starting point to the end of the chain to close the polygon. Now we will move on to parallel and anti-parallel vectors. When vectors are parallel, you add them to find the resulting force acting upon the object. So for example, let's call this vector, vector A, and it has 7 newtons of force. And vector B has 2 newtons. The resultant vector will be vector A plus vector B, which will be equal to 7 plus 2, which is 9 newtons. In antiparallel, you subtract the forces. So let's call this one vector C and vector D. And vector C is 10 newtons of force, while vector D is 1 newton. The resultant force will be C minus D, which is 10 minus 1, 9 newtons. So, a very important point to note is that you always have to state which direction the vector is going. So in this case, it has a resultant vector of 9 newtons, but we know that vectors have magnitude and direction. So you will say 9 newtons to the right, and same will be done right here. So 9 newtons to the right. Now perpendicular vectors. In the case of perpendicular vectors, as you can see, if you were supposed to extrapolate, it would make a right angle. To find the resultant vector of perpendicular vectors, you find the resultant vector of the horizontals first, and then the verticals. So, finding the vectors of the horizontals, we'll have 6, and as we know about antiparallel vectors, minus 2, will be 4 newtons. So note our horizontal vector has a resultant force of 4. And our vertical will be 4 minus 1, which will give you 3. And remember, always remember, to the right, down. So now we have our two values, 4 newtons and 3 newtons. We can create this right here. So we'll have 4 newtons to the right, 3 newtons down, acting upon a point. And as we know about the parallelogram method, we reconstruct vector, let's call this vector vector A, and mimic it over here, and vector B over here. And then you join the points to find the resultant vector. And seeing as this is a right angle, because it's a perpendicular vector, we can use Pythagoras' theorem. So as Pythagoras' theorem states, a squared equal to b squared plus c squared. In this case, r will be a, and this will be b and c. And there you have it. So R has a force of 5 newtons. Many of you will know this already because this is a famous Pythagorean triple, 3, 4, 5 for right angle triangle. And now to find the angle at which R goes down. So to find the angle at which it goes down, it will be tan inverse (3 over 4). And that will give you, if you put it in the calculator, 37 degrees. And to finish off vectors, I will be showing you a technique called resolving vectors. This is where vector A can be written as the resultant force of two perpendicular vectors, y and x in this case. In order to find A or y, you can use sine theta is equal to y over A. In the case of A, theta and x, cosine theta is equal to x over A. So, for example, if theta is equal to 30 degrees and A is equal to 40 newtons, then sine 30 degrees is equal to y over A, which is 40 newtons. Therefore, y is equal to sine 30 degrees multiplied by 40 newtons. So sine 30 is a half times 40, and that will result in y being 20 newtons. And that's it for vectors. Thank you for watching ABT, and see you next time.